6.4 deals with the sine law. The sine law is used to solve problems in triangles that are not right triangles. So the sine law has three ratios to it, and it can be solved for any triangle such as ABC or XYZ or whatever. But it looks like this: A over sine A is equal to B over sine B, which is equal to C over sine C, or sine A over A is equal to sine B over B, which is equal to sine C over C. Now, we have to identify what sine A, sine B, sine C, and ABC are. So if I have a triangle, this is not a right triangle, and this is A, that means little a is opposite. If this is B, that means little b is opposite. And this is C, angle C, then that means little c is opposite. So, and we have the problem. Number 1, and we want to find the length of PQ. And we have the triangle that looks like this. We have P, we have R, we have Q. So opposite R is little r, opposite P is little p, opposite Q is little q. But they tell us Q is equal to 8.1. They tell me angle P is 75 degrees and angle R is 39 degrees. So once again, we will identify which one we're going to use. So I have A over sine A is equal to B over sine B, which is equal to C over sine C. Now I'm going to replace my triangle. It is dealing with triangle PQR. So then I get P over sine P is equal to Q over sine Q, which is equal to R over sine R. I'm going to substitute my measurements. So I have P is nothing there, sin 75, Q is 8.1, and Q I do not have. However, all angles in a triangle add up to 180 degrees. So 180 minus 75 minus 39 is equal to 66. So that means sine Q is 66. And then R I do not have, and I have sine R is sin 39. Question is to find PQ, this distance. So I got to find R, so I'm going to take any two ratios. Now, because there's a number here, a number there, a number there, I'm going to take these two. It's no good taking these two measurements and these two because there's two variables that are not full. So I take in these two. I then have 8.1 over sin 66 is equal to R over sin 39. From there, I'm going to multiply both sides by sin 39. Sin 39. These cancel out, so now I'm left with sin 39 times 8.1 divided by sin 66 will equal R. When I do my calculations, I will see that I end up with 5.09749 divided by sin 66 is equal to R, and R is going to be equal to 5.57, which is a measurement of PQ. Now, if I have a different problem, such as problem number 2, let me get it adjusted here. Problem number 2, where I have to find angle J. Once again, I have the triangle, and the triangle may look something like this, where I have G, H, J. I have 8.6, I have 6.1, and I have 65. And they're asking me to find angle J, so I got to find this angle there. So once again, my formula Sine law is sine A over little a is equal to sin B over little b is equal to sin C over little c. Now I'm dealing with triangle GHJ, so it's going to be sin G over little g, and it's going to be sin H over little h, and sine J over little j. Substitute the measurements. So sin G I do not have, G, which is opposite, I do not have, so I just replace that as sin G over little g. Sin H, I have 65, so I have sin 65 over little h be opposite big H, so that's 8.6 is equal to sin J, which I do not have, over little j, which is opposite big J, which is 6.1. Question says find angle J, so that's the one I'm going to work with. I'm going to take this ratio beside it because there's two numbers there, and this one has no numbers. So then I follow through, and I go sine 65 over 8.6 is equal to sine J over 6.1. Multiply both sides by 6.1 to get the variable by itself. These cancel off. So now I have 6.1 times sine 65 over 8.6 is equal to sine J. 6.1 times sine gives me 5.528477. Do not reduce that, just leave it in your calculator. Divided by 8.6 is equal to sine J. And once I divide that in there, I get 0.6428 is equal to sine J. I need to change this into an angle, this measurement into an angle, so I use sine -1. So sine -1.6428 will give me 40 degrees. So angle J is equal to 40 degrees.